Right, figure 3 shows part of the curve with equation y is 3 cos x. The point PCD is a minimum point on the curve, with C being the smallest negative value of x at which a minimum occurs. State the value of C and the value of D. So the value of, let's just make that bigger. So what we have is a cos graph. We've got 3 here at the front, so it means that our curve has been stretched by a factor of 3. This is minus 90, this is minus 180. So point C is going to be minus 180 minus 3. Part B, state the coordinates of the point to which P is mapped by the transformation which transforms the curve with equation y is 3 cos x to the curve with equation 3 cos x over 4. So what's happening is that the x value or the x values you have to multiply by 4. So this value here you times by 4, because a quarter means that it's a stretch by a scale factor of 4 in the x-axis. So we would have 7 minus 720 minus 3. We have y is 3 cos x minus 36. So this one here, if we've moved or transformed to the right, so we're going to move right by 36 degrees. So the same coordinate P, so P is minus 180 minus 3. We're going to add 36 to minus 180. So add 36 to this point. It's only the x values that's been moved. So we would have minus 144 minus 3. So that concludes our part A and part B. Part C, solve the equation for the range 450 to 720. 3 cos theta plus 8 theta, and give your solution to one decimal place. So a clue, they've given us one solution, so not solutions. So we're going to look at the equation. So y is, actually it's just 3 cos theta equals 8 tan. Because we've got tan in there, we can't really do much with it unless we kind of convert it to its other form. So we have tan theta is sine theta over cos theta. So now we could now write this side as 8 sine theta over cos theta, and this side is 3 cos theta. We times both sides by cos, so we have 3 cos square theta is 8 sine theta. Now we need to solve the equation when they have the same trigonometry identities. So we're going to possibly change the cos square theta instead. So remember our formula, so sine square, so our trigonometry rule is that. So sine square theta plus cos square theta is 1. So cos square theta is 1 minus sine square theta. So we're going to replace our cos square with that expression. So 1 minus sine square theta equal 8 sine theta. We're going to expand the bracket. We're going to make one side equals to 0, so it's probably best to move over the minus 3 sine square theta minus 3 is 0. We need to factorize that. So we know that it's going to be 3 sine theta and one of them here, 1 sine theta. We need to have a value that when you times it by 3 add 1 you get plus 8. So we're going to have, I think, a plus 3. Yeah, that would work. So plus 3, and on this side we need to have a minus 1. So we've got two solutions. Well, we've got sine theta is 1 over 3 and sine theta is minus 3. Now we can't have this value, so that goes. We're then going to find out what theta is, so we're going to do the inverse of 1/3, and that comes to 19.47122, something like that. Now the range is between 450 and 720, so we can't use the 19.4. So I'm just going to draw a sine wave. So we're going to have right, so we want it between 450 and 720. So this point here is 360. This point here is 720. 450 is going to be this area here, so that's 450. This is going to be 540. Okay, now 19 degrees roughly would be here. And then another one would be here, another one would be here, another one would be here. The range that we need is this range here. So the only value we have is this point here. So now to work out that value, this is going to be 19.47 degrees away from 540. So theta is going to be 540 minus 19.4, and the answer would be 19.477122. And so if we round that to 1 decimal place, we would have 520.5. So the answer is 520.5 degrees. Okay, thank you for listening.